You've heard of shapefiles, you've probably worked with GeoJSON, but there's a new format changing how we handle spatial data, and it's not even a GIS tool. It's called GeoParquet, and it's built for the modern data stack, not just the map viewer. If you care about working with big data, running fast spatial queries, or building pipelines at scale, this is a format that you need to know. Today I'm going to break down what GeoParquet is, why it matters, when you should and shouldn't use it, and how it's going to reshape the future of geospatial data. So first, let's talk a little bit about what GeoParquet is. GeoParquet is based on the Apache Parquet file specification, which was originally developed by Twitter and Cloudera in around 2013. It was developed as a part of the Hadoop ecosystem, which is a big data processing system that allows you to do distributed processing across lots of different data. And it was really built to solve the problem of inefficient storage and then also the slow querying of big data that was in distributed systems. It's a really efficient file format. And we're going to take a look at all the different pieces that go into that, but it was specifically designed for columnar storage, right? A lot of data, if you think of anything like a shapefile, a spreadsheet, a CSV, whatever it is, it's in rows, right? So you have an individual row and each of those rows, there's different columns, right? This data type is focused on columns, right? You pull out the columns that you need, and within all those different pieces, there's a lot of efficiencies that can be gained. Parquet has been traditionally used in big data processing systems, things like Hadoop, like I mentioned, Spark, Presto, Hive, all these different projects, and now in new geospatial projects, it's being used as well. Things like Apache Sedona, DuckDB, and other systems that support spatial querying. The most important piece is that it allows for us to efficiently compress and partition data, right? Those are two big pieces that you need to know about this, and allows us to work across large-scale analytics. So what that means is you can use read-heavy analytics workloads. You want to read in a lot of data and get a query back. Imagine you want to just pull in data from a bounding box, or you want to do a point and polygon join and you want to aggregate data. Those are all different workloads that you can use, and GeoParquet is a good files type choice for. You still need a query engine, and using distributed query engines work really well with GeoParquet. And it also enables for like push down of reading filters across the data set before you actually have to pull anything in. So with that, let's talk a little bit more about GeoParquet and some of the specifics that add into that specification. I know I said specifics 5 times, but that's part of the piece here. So GeoParquet adds a geospatial column into Apache Parquet, right? It's really just a data type Parquet with geospatial support. It's nothing different or new, it just adds that in there as well. It also adds spatial metadata onto the file and then different parts of the file as well. So if you think about the coordinate reference system or CRS, if you look at different elements like bounding boxes, all those pieces can be added into that spatial metadata, which can be read even before any other data gets read into the system. So it already knows how to handle some of those different things. Now, there's a few different pieces that are really important to understand about Parquet and then in turn GeoParquet. First is that columnar format, right? Each part of the data set is stored in a column, right? So if you have columns A, B, and C, maybe one is an integer, one is a string, and then one is a float or decimal point. And then finally you have a geometry column, right? Each of those is stored in an individual column. Now when you query that, you want to select only column A and the geometry. It can skip over the rest of the data set because it just looks at those columns. Now within the entire data set, you also have partitions. Usually GeoParquet is not just a single file, right? It is actually split into multiple partitions. Now you can partition that traditionally by things like a date or maybe a string value like a state or something like that to split the data up, right? If you're querying across those things and you commonly want to filter data out, you can actually skip over that using partitions. Increasingly, we're using spatial as a element to partition your data, spatially partition. There's lots of ways to do that. Here's a great blog post that actually looks at how to do that for reading and partitioning large spatial data, but you can think of things like spatial indexes and even more advanced methods like a KD tree as well. There's still like an active debate on how to do this, but it basically allows you to split the data up in even spatial groupings, right? So you know you have more data in your cities, less data in your rural areas. It allows you to split that up quite evenly. This is really helpful for vector data because it is unevenly distributed, unlike raster data, which is basically there's something at every point in the TIFF file. It's the same size, same everything in that. So you don't have that same problem with raster data. Now within these partitions and rows, there's a partition is basically just a file or split up files or stuff like that. This is a view of what that would look like. Here's some partitions and here's what the data looks like. You also have row groups. Now within a row group, you can split up and group these rows efficiently as well. So you can choose how to do that. The people that write the files choose how to to do that. They can be split up in numbers of 10,000 or 100,000 or whatever that might be. And there's different ways and different efficiencies that are gained with that. But let's just, for this example, think of we have 5 row groups, or there's 5 rows in each row group, right? So let's imagine you have a spatial query. You want to find everything inside of a bounding box around a city, let's say Dallas, Texas, right? Now, imagine this is a nationwide data set. You want to eliminate as much data as you can as quickly as possible. Now, just with the partitions, each file, right, a partition is just a set of files, right? Each file has that spatial metadata on it that includes a bounding box, right? So it can say, okay, does this file even intersect this query? Yes, I can study it deeper. No, I can just ignore it completely, right? And this is all about getting rid of as much data as possible based on your query. Now, within the row groups, you can also add a spatial metadata bounding box to say, okay, now that I'm in this file, can I skip over this chunk of 5 rows, or in this case, 10,000 rows or 100,000 rows? So it just adds all of these efficiencies into the data itself. And then finally, there is extra compression on the files themselves. You can actually compress them using a number of different methodologies to do that. Once you compress them, they get really small and tiny, and that adds a ton of efficiency on top of that as well. So all of these building blocks, all these pieces, in turn make it easy for you to query large amounts of data. So let's get into the next section. Why should you even care about this? So if you're working with large scale analytics, like you're asking these really big questions across nationwide data set, millions of rows or anything like that, or you want to retrieve that data, then GeoParquet matters to you. Specifically, and I know a lot of people that are coming from GIS workflows, why should I care about this? Well, if you are on a desktop GIS and you want to read in a very large data set, let's say Overture Maps Foundation, it's built in GeoParquet, and you can basically leave that whole data set on the cloud somewhere, wherever that is, and use a system to just read the pieces of that data that you need, right? It makes it very efficient to go read this entire data set, query what you need, and just bring that into your desktop GIS. So if you're reading spatial data or want to use large-scale spatial data, this matters to you because of all those efficiencies I mentioned in the first section. If you're producing data, this probably matters just as much as well, because you want to get that data into people's hands as efficiently as possible. When you add in the cloud-native workflows, you can read this data over HTTP, you can stream it in chunks, you can filter without loading the entire files. All those things make it just faster to consume data. So as data gets increasingly larger, these types of workflows become increasingly important. You can read much more data quickly, faster, efficiently, and not have to pull as much data from the cloud onto your system. That's one of the tricky parts with the name cloud-native spatial data. It makes it seem like you need to use the cloud, but you certainly don't. It just is about where you store the data, how to read it efficiently, and all these different things. At the end of the day, this just makes spatial data a first-class citizen in modern data stacks and modern data systems, right? It's supported increasingly by lots of different tools: GeoPandas, GDAL, PyArrow, Apache Sedona, DuckDB, and lots of other modern data systems, things like BigQuery, Snowflake. All these different systems and tools are supporting it. You can see a full list of those here, and I'm not going to try to name all of them because there's more being added and increasingly more are coming on. So by the time I record this, it's probably outdated. But go check this link here. You can see the full list of tools that support GeoParquet reading. All right, now for this next section, we want to decide, do you actually need to use it? I've broken this down into 4 different categories, right? So the first is personal projects, right? Do you need to use this if you are using personal projects? And I would say maybe, right? If you're learning SQL or want to experiment with larger spatial data types, reading them from large cloud data sources, yeah, you definitely need something like this. This will make it a lot easier, specifically if you're working with vector data. If you want to compress the data onto your system, or you're reading and storing data, this is another good thing. But if it's personal projects, you can kind of do this at a small scale. You don't need to go crazy with this. So if you're just experimenting with desktop GIS, you want to use shapefiles, it's probably not something you need to jump into right away. But if you want to work with larger data sets or read data from cloud data sources, then yes, this is something to keep an eye on. If this is for a one-off project, meaning specifically something that has a specific start and end, you're not continually collecting the data, this is another maybe, right? If data is already in one format and it works and it loads and everything works fine, you're probably okay, right? You don't need to transfer data unnecessarily to another format just because, right? But if you're moving large data sets into that project, if you need to store that data efficiently once the project's done, GeoParquet is a really small file format, so that can make it really efficient. And if you're using any of those tools, then it makes it another better fit as well. But again, you just don't want to unnecessarily turn a format from one to another just for just for fun, basically. There's no point in doing that. Now, the next two sections, I look at small teams and then enterprise scale teams. So if you're a small team, this can really help bridge GIS and data engineering workflows. If you have a team that's like constantly collecting data, they're streaming it from sources, they want to keep it in one central place, GeoParquet is a really efficient way to do that. And you can actually distribute that to lots of different GIS systems. If you're using ArcGIS or QGIS, if you have teams using GeoPandas or whatever, it has that interoperability and an ability to use larger formats, right? So if you are doing things like that using, notebooks, desktop GIS, databases, cloud platforms, yeah, it can work. I'm not saying to rip out your entire system as it is today, but if you need to start to collect these larger analytical scale data sets, right, then it's something to start to think about. Now, if you're working in an enterprise, and I would describe enterprise as any large company, right, that has many different teams using lots of different systems, increasingly modern data stack tools, be them in the cloud or different data processing systems or things like that, it becomes increasingly more essential to have interoperability. And GeoParquet provides a lot of interoperability between these different systems, right? You can pull this into distributed processing systems, be it Spark, Whereabouts, Apache Sedona. You can pull it into data warehouses like BigQuery or Snowflake or Redshift. You can share it across data science workflows. Your data engineers will understand it. So once you get to that level, it allows you to build this, scalable spatial data lake or data lakehouse, and do that efficiently in tools that people already understand, right? So if you're doing that, that certainly becomes a way for you to better pair yourself with all these different teams and not leave yourselves isolated using, trying to scale a GIS server or sending map tiles to someone who doesn't know what that is. It becomes increasingly important there. So that's kind of how I would rank these four categories. For personal projects, I would give it like a 3 out of 5 in terms of importance. For one-off projects, 2 or 3 depending on your need there. Small teams, 3 or 4, basically looking at, how much analytical work you have to do. And then if you're in the enterprise, probably a 4 or 5, pretty important there. Okay, so how do you actually use it? Well, to get started, I would definitely start working with GeoPandas. That's probably the easiest way to do that. You can turn any format from one file type, like a shapefile or a GeoJSON, into Parquet, right? It's easy to turn those over. And then you can start to experiment with some different things there. If you're just getting started as well, DuckDB is another great tool as well. Or you could actually, install Apache Sedona locally, experiment with some Spark workloads, and actually write some files out that way. Now, you can always store this data locally. You can just pull it onto your desktop and store it on your computer. Or if you want to integrate this into cloud storage, you can do that too. I actually have a course that looks into this. So if you want to check that out, you can check out the link here and actually experiment and build this into a full course as well. Now, if you're building out full data pipelines like ETL transformation, stuff like that, there's a few different things you might want to check out as well. You want to have some orchestration layer. I've seen people use FME for this. I've seen people use Apache Airflow. Personally, I prefer Airflow because it fits into my Python workflows, but there's no right or wrong answer here. So that allows you to have some tooling to increasingly do this over time and then manage how you overwrite the data or rewrite the data and stuff like that. So that's another thing to start to look at how you can do that. But the tools that support GeoParquet are increasing nearly every couple months here. Now, if you're just getting started with GIS, you can use QGIS with, GeoParquet. There's a plugin to do that here, and there's a blog post that sort of describes that. On top of that, I think you can also use ArcGIS Pro, so I think they add some support for that, but I'm not sure. I don't use Esri on my day-to-day, but you can check their documentation. I think they're adding those different things. So more importantly, when do you not need to use this, right? There's a lot of reasons why you should use it. If you're editing and doing interactive map work, like editing lines and kind of maintaining geospatial data on a desktop toolkit, that's something you don't need. You can use GeoPackages, shapefiles, all these different tools that already exist for that. You should be good to go there. On top of that, if you're tiling data and serving data over the web as a map tile layer, that's again not the right choice. Things like your GeoServer or tools like that, you can use those. You can also use PM tiles, which is another cloud native format to do this as well. But there's lots of choices when you're creating tiles as well. But GeoParquet unfortunately isn't the right choice for that. If your toolkit doesn't support Parquet, that's another thing to think about. If you're not using that on a frequent basis, what would be the lift to migrate to something like that? That's another thing that you want to consider. And then I would also say if you're using like complex topology or CAD-like data sets, you need to fit into a specific format. That's another time you should kind of consider, okay, do I really need to transfer this or not? And finally, when like a simple CSV shapefile GeoJSON is just enough for the quick task, there's no reason to add an extra step there to turn it into another format. You don't need to do that. If it works, if it scales, if it's, does what you need it to do, stay with that. And when you get into the larger analytics workloads, now hey, GeoParquet is there when you need it. Now, a few pitfalls. It's not, as of the recording of this, universally universally supported in all tools. There's some support in QGIS today and ArcGIS, but I think that will continue to evolve over time. If you're writing these files, there's a few specific things you want to do in terms of ordering and sorting the data and partitioning, right? I mentioned that course earlier. There's all those kind of best practices built into that. There's a lot of different ways you can do that, and the performance will depend on your query engine. You need to understand how your query engine works and filters out data. So depending on if you're using Apache Sedona or DuckDB or different systems there's different things that each query engine will optimize for. So understanding the query engine that you choose will also determine how you build your GeoParquet data files. If you're interested in actually building out and writing like very large volumes of geospatial data, I have a tutorial on whereabouts. You can actually check that out here and actually build in some of these best practices to efficiently write GeoParquet data. Now, importantly, and I know if you've ever talked about metadata, you're probably bored of talking about metadata, but make sure you have your metadata set up correctly, because that adds in all those efficiencies that I mentioned before, right? It allows you to filter out all these things spatially, and then even the way you sort and order your data is really important. One thing I didn't mention earlier is basically within the individual rows, if you repeat different values, it will effectively skip those over. So let's say you have a column, and here's an example of 5 rows that go 1, 1, 1, 2, 2. Those second 2 ones will actually just not be in the data set. They'll just skip it because they know that the next couple values are 1, right? And the 2 will skip the second 2. Doing that with geometries makes it really efficient to store that data, right? You can order the geometries, and if you have repeated geometries, you save a lot of space. So that's another thing that, is important here, and the spatial metadata allows you to do some of that different querying and ordering really efficiently. So you don't want your, polygons or your geometries all over the place. Order them and do these things, and you'll save a lot of headache and basically query speed and everything downstream from that. Finally, each of these different tools have different compatibility for read and write workloads. Some can just read them in, some can write GeoParquet, so you need to be aware of what those tools can do. So finally, where can you learn more? There's an official repo here for GeoParquet. You can check that out. I would also check out some of the cloud native geospatial guides here. I'll put a link here as well. These have a lot of good information on what that is, and it's a great resource to check out. There's lots of different writing and blog posts about this as well, so increasingly there's lots of different things like that. There's a great community forum on the GeoParquet GitHub as well, and then I've also done some different writing about this over time. You can check that out here, and if you're really interested, like I said, I have this notebook that you can check out to write GeoParquet efficiently using whereabouts and Apache Sedona, or if you're interested in getting to do this with other tools, you can check out this course as well, and you can actually do some of these different things as a part of the Spatial Lab. So with that, that's my overview of GeoParquet. I hope you enjoyed this video. I'm testing out this new format just to really do deep dives on specific technologies, and there are a lot of technologies in our space. If you like this format, let me know, drop that in the comments, and let me know which technology you want me to cover next. I'll see you there.